the graphs of the functions f of x equals the magnitude of x minus 3 and g of x equals 2 are shown in the diagram. Find the coordinates of the points A, B, C and D. In another video I've explained how to graph the magnitude of a linear function like x minus 3. X minus 3 is linear. If we just looked at the graph of y equals x minus 3 without getting the magnitude, we would have a line, a straight line like this here, passing through the point C and continuing on indefinitely. C is the value of the function, is the value of x that makes the function equal to 0. C is actually 3, because if we plug 3 in here we get 3 minus 3 equals 0, whether or not we get the magnitude. The magnitude of 0 is just 0. Anyway, y equals x minus 3 is this line here. But if we get this function, the magnitude of x minus 3, then all the values of x that make y negative will make y positive. For example, if we take this value of x here, we're going to get some negative value. But when we get the magnitude of a negative number, it becomes positive. So we just reflect that value through the x-axis to get its corresponding positive value. So for example, if this value gives, say, a value here of minus 2, say the y value of this point is minus 2, when we get the magnitude of minus 2 we get plus 2. So this part of the function y equals x minus 3 is reflected through the x-axis. So we reflect the part of the line that is below the x-axis through the x-axis. So we get this V shape. Now, the other function, g of x, is just a constant. It's equal to 2. So g of x cuts the y-axis at 2. So all the points on this horizontal line have a y value of 2. So the y value of the point A is 2, and the y value of B is 2. So let's get the coordinates of point A. Well, let's just go through it. We have f of x equals the magnitude of x minus 3, and we want this to equal 2. F of x is the y value of a point, so what's missing here is x. So f of x must equal 2, and A is a point on the function, or the line, y equals the magnitude of x minus 3, so it's got to satisfy this equation here. If we plug x in here, get the magnitude of x minus 3, we must get 2. B has the same form. Its coordinates are x comma 2, but of course the x value is going to be different, so we're going to get two solutions to this inequality. So when we're solving an inequality that involves, or an equation I should say, that involves a magnitude, we have to consider two cases. The first case is where the quantity that we're getting the magnitude of is positive, or 0 we could say. In that case, the magnitude of the quantity is just the quantity itself. See, if x minus 3 is positive or 0, getting the magnitude of it doesn't do anything. So we just have to solve the equation x minus 3 equals 2, from which we get x equals 5. You can see from the diagram that since this point here has coordinates 3, 0, because when we plug 3 in we get 0, that this point here must have coordinates 5, 2. So we must be referring to point B for this case. The second case is where the quantity that we're getting the magnitude of is negative. Suppose x minus 3 is negative. So there's only two cases. Either x minus 3 is greater than or equal to 0 or less than 0. There can't be any other case than that. So if we want to get the magnitude of x minus 3 when x minus 3 is negative, what do? We just stick a minus sign in front of what's inside here. So if x minus 3 is negative, by sticking a minus sign in front of it, we make it positive. And that's what we want to do, because we want to get the magnitude. So now we have to solve this second equation. We could actually bring the minus sign over to the other side and write x minus 3 equals minus 2. It's like multiplying both sides by minus 1, or we could take the minus sign in here, it doesn't matter. And solving this, we get x equals 3 minus 2 is 1. So that's the coordinates of point A. The coordinates of point A are 1, 2. The coordinates of point C, as we saw already, are 3, 0. Now what about D? Well, D, the x value of D is 0. So if we just get f of 0, we will have found out what the coordinates of D are. So we want a magnitude of 0 minus 3. Well, the magnitude of 0 minus 3 is just the magnitude of minus 3, which is plus 3. So D has coordinates 0, 3. Next, we want to solve the inequality, the magnitude of x minus 3 less than 2. Well, this is part of the graph of the magnitude of x minus 3. And this line here, this line segment is part of the graph of y equals 2. So I'm showing y equals 2 in blue, and I'll do the other one in a yellowish color. This is y equals the magnitude of x minus 3. We can see that for values of x along here, the magnitude of x minus 3 will be less than 2. So for example, if we take this value of x here, we see that the magnitude of x minus 3 is some value that is less than 2. That's true for any value of x in this region between this point and this point here. Well, this point is x equals 1, and this point is x equals 5. So the solution to this inequality must be 1 less than x less than 5. So any value of x in this region here, excluding the endpoints, because we want the magnitude of x minus 3 to be strictly less than 2. Of course, that's using the graph, so that's following on from the previous part. Now the other way of doing it, well, I've explained that in other videos. I won't bother going through it again here.